Proximity fan, Sheldon Chu, and James McCormick.
So,
Alright, we have 2 more to go. Counting this one.
almost there. We're done.
Alright, I'm James McCormick.
Sheldon, too. I guess we're saying last names too. How they run. Anyway, our project was the proximity fan, as we will explain in the next few slides.
Alright, so what our project is it's a fan that, depending on how close an object is to a rangefinder, it will vary in speed. The closer you are to the rangefinder, the faster the fan will rotate. And this is done through a motor, which is the fan essentially. A motor driver that powers the fan, and then an ultrasonic rangefinder, which will detect how far you are. We also implemented a button that will alter the speed depending on how many times the button is pressed, so it has a high, medium, and low speed. And we also have a switch that will basically just turn on and off the motor driver, which will turn off the motor. Specifications, we found that the motor driver, the ultrasonic rangefinder will output approximately 10 millivolts per inch. So using that, we were able to use the analog to digital converter on the Arduino, so that to create a digital voltage that would be sent to the motor driver by a pulse width modulation.
Yeah.
And yeah, basically by that, the pulse width varies depending on how far away the person is, and through that will determine how much the motor will spin.
Okay. This is our really detailed system block diagram. We have our 4 basic components. Is it 5? This is 5. We have our external power supply, which is supplying power to our motor driver, which runs from anywhere between 6 to 15 volts. Increasing that voltage will increase the amperage supplied to the motor, which will increase its speed. Our Arduino's ADC takes in an analog voltage signal, as James said, from the ultrasonic rangefinder, and then converts that into binary code, which is sent to, or is decoded, and what is it? It's like that output is set to AN1 and AN2 of the motor driver, or the motor driver. And our motor driver can actually run 2 motors at a time on outputs A and B. Sorry, the font's probably really small for you guys, but right now all we're doing is just controlling 1 motor, and we're sending a pulse width modulated signal to AN1, because how the motor driver works is if AN1 and AN2 are both high, then it won't operate the motor. If it's high and low, then it'll spin it in one direction. If it's low and high, it'll spin it in another, or clockwise and counterclockwise, basically. And if they're both low, then the motor just turns off. Additionally, there's also a standby feature for the motor driver. So if this, I think it's an active high, or active low, sorry. So if the standby input is low, then no signal will be sent to the motor, or nothing will be applied to the motor, and the motor will not activate. If it's high, then everything runs perfectly. I think that's all as far as it goes.
Alright, so basically, to overview how both software and hardware works, turn on the unit, and then we initialize the timers on the Arduino, and then we also need to make sure the analog to digital converter works on the Arduino. Then through interrupts, or actually through polling, we're able to use the ultrasonic rangefinder and the button switches. And yeah, as we said before, the button will alter the duty cycle. It will go from high to medium to low, and then back to high, depending on how many times you press the button. And the rangefinder will affect the duty cycle of the signal being sent to the motor driver. Before that signal is actually sent to the motor driver, you need to make sure that the motor driver is on based on the switch. If it's off, then nothing will happen, but if it's on, then the motor driver will supply power to the motor based on the pulse width modulation, and then it just repeats over and over again from there.
And then lastly, to sum it up, everything works more or less. That's about it. And so we have our demonstration on our bench. Unless anyone has questions about our design or.
Let's see it.
Well, just like looking at it intently. So. Okay. So we were a little lazy in making fan blades, so we just attached some electrical tape to the end of our motor.
Any fan blade could be made and attached to the motor, but there's just lack of time on our part.
And then here's our ultrasonic rangefinder, so we're actually gonna have to have this area cleared.
Yeah,
Sorry.
it's come this way because it could detect a lot of things actually.
So we're gonna apply, let's just do 8 volts. It's kind of obnoxious, sorry. So basically, under about 3 feet from the sensor, so I'm under 3 feet, it'll be at its max speed. Over that, from 3 to about 4.5,
Yeah.
it's another speed.
And
then once you're greater than about 6 feet, it just turns on.
that's awesome.
And
Yeah.
then we also have
We have buttons.
just
Shoot a little slower.
less obnoxious. When you bump the switch, man.
Those switches are terrible.
Those switches are terrible.
They just fall out of the pool.
So right now our switch. Oh, stop bumping the switch. Okay. Switch is high, so it'll activate. Switch is low, turns off. And that's basically
And
it.
as well too, the maximum speed.
And
That's it. That's all.
It has a kill switch.